Okay, we'd solved exponential equations earlier, but when we did it then, we always could make it so the two bases were the same. Like maybe one was a 2 and one was a 4, so we changed 4 to 2 squared. But you know how mathematicians are. They're like, let's try somewhere you can't make the base the same. So there's no real way to make 5 a power of 7 or 7 a power of 5. So what's a boy to do? Well, it turns out we use logarithms. So we're going to take the natural log of both sides. Because now that you know the properties of logs, you know what can happen to this x. Where can we move it? That's right, we're allowed to move the exponents down as coefficients. So x times the natural log of 5 equals the natural log of 7. And then we just divide both sides by the natural log of 5. So we find out x is 1.209. That's it. That's right. But wait, there's more. Let's say we try this one. It is worth checking to make sure you cannot rewrite them as a base of each other. You can test it out. You can do 7 squared and 7 cubed and 7 to the 4th. None of those are going to equal 813. So when we cannot make them have the same base, that's when we use logarithms. And just so you know, you can use any logarithm you want. You can use common log, natural log base 11. I usually use natural log for a reason you'll see in a later example, but truly all of them work, as long as you use the same one on both sides. Natural log, yeah, the ln. Same as this before, we'll bring the 0.3x out front. Divide both sides by the natural log of 7. Okay, this isn't our final answer, because 3.443 is equal to 0.3x. Sorry, 3.443. And it's completely fine when you're writing your work down to just round it, but our last step is to divide by 0.3, and in the calculator I want to just hit divided by, so it will use that exact answer, so it's using the exact number and not just a rounded version. I divide by 0.3 and get 11.478. So good? Okay. But there are times we have to do other work before we get there. Because one thing that's been true of the examples so far is that the exponential was already by itself. This time it's not. We need to get it by itself before we use logarithms. Close. Add the 40. Yeah, add the 40 to both sides. Yeah, so we'll add the 40 to both sides, and we'll divide both sides by 5. Now that the exponential is by itself, we take the log of both sides. And here's why I like to use natural log. Because what do natural log and e do to each other? Yeah, they get rid of each other, so because they're inverses, so that just leaves 0.6x on the left and natural log of 48 on the right. So then we just divide both sides by 0.6. So 6.452 is our x. try one more. Negative 10e raised to the 2 minus 2b minus 6 equals negative 66. That's right, we add the 6 to both sides. And then, divide by negative 10. And now we do have the exponential by itself, so we'll take the natural log of both sides. Cancels out the e, or technically just undoes it because they're inverses, but anyway, leaves the 2 minus 2b equals the natural log of 6. Then we'll subtract 2 from both sides. So I'll go ahead and let the calculator help me out here. Natural log of 6 minus 2. So negative 0.208. Yeah, natural log of 6, then subtract the 2. And then the last step will be to divide both sides by negative 2. Again, if I just hit divided by, it uses the exact number in my calculator instead of just a rounded version of it. So we get positive 0.104 is our answer. One more challenging problem is one like this. And it may seem like, well, what in the world do we do when there's more than one e to the x, and one of them is e to the 2x, and one of them is e to the x? Well, you don't have to write the step I'm about to, but I think it might help you see what we do. E to the 2x can be rewritten as e to the x squared. Think about it, you can simplify e to the x squared to e to the 2x. So one way you can think about this is, what if we just traded e to the x for just x? Then it just looks like we have x squared minus 3x plus 2 equals 0. And if it was that, we would just factor. And that's exactly what we'll do here as well. Let me move the x over. Okay, there we go. I'm just getting rid of the x. There it is. Okay. So we're actually going to factor this as well. The only difference is we're going to put e to the x in front instead of x in front. Then we, just like normal, we think what will multiply to be the positive 2 and add up to negative 3. That'd be negative 2 and negative 1. Then we set both of those equal to 0. Over here I'll add 2 to both sides. Over here I'll add 1 to both sides. And then I'll take the natural log of both sides. That cancels out the e's, leaving me just x on the left, and natural log of 2 here. X on the left, natural log of 1 here. And you can certainly plug those in to get the decimals if you want, but those are our answers. So that's how to solve exponential equations when using logarithms.